Hey guys, this is the third part of examples of really a four-part series where I've been talking about increasing and decreasing functions in the first derivative test. As a reminder, pause and try the examples, and there are free guided notes available. Also, if you could do me a solid, please consider giving my video a like or subscribing to my channel, share it with your friends, or leave me a comment of how I can make it better. I'm trying to provide as much good free instruction for math on the internet as I can. I am a one-woman shop, and your support means the world to me. All right, so in these examples, we're going to identify the critical points, identify intervals of increasing and decreasing, and identify any local or global max or min values if we can do that as well as we can. So we're going to look at kind of tougher examples in this case. So let's start with f of x equals x squared minus 4x minus 8 times the natural log of x. So what I want to recommend to you is that you actually try to just do this problem in its entirety and then hit play when you think you're ready to check the entire solution. Otherwise, if you think you're getting stuck and you just want to hint on the solution, hit play when you're ready. Okay, so first things first, I have to find the first derivative, which is 2x minus 4 minus 8 over x. And I also have to find my critical points, so now would be a good time just to note what the domain of this is. So the domain of this, because of the natural log, the domain is all x's have to be greater than 0, so that's kind of the restriction. So this is important to know because for critical points, we could say, oh, 0 is a critical point because the function does not exist there. However, it doesn't matter because it's not in the domain. Okay, so then all I have to do is set this function equal to 0 and really just solve for it, right? And probably my best course of action here would be to just multiply everything by x to get rid of this fraction here. So if I just go through and multiply everything by x, this now will become 2x squared minus 4x minus 8 equals 0. And then you might think to yourself, oh, I could totally factor this. So then you factor out the 2, and then, oh darn, you really can't actually factor this. So you got to use other methods. Now, usually what most people think of when they can't factor is the quadratic formula, so I'll go ahead and just do that. So let's identify what are our a, b, and c. So my a is 1, my b is -2, and my c is -4. Now, if you are watching the solution, I would highly recommend maybe you pause here, work this out, and try to see if you can set up the table, and then hit play when you're ready. So I'll go ahead and work out the solution. So this will become 2 plus or minus the square root of -2 squared minus 4 times 1 times -4. All of this divided by 2 times 1. So if I work all that out, this will simplify really to just 2 plus or minus the square root of 20, all of that divided by 2. And so in decimal form, I get two decimals. The first one is 3.236, and the other one is -1.236. However, we know that this negative one won't work because it's not in the domain, so we can just toss it out. Okay, so I've written a whole bunch of stuff here, so let me clear all this out and just make some space so we can keep going. And so now what I recommend that you do is set up the table if you haven't yet around your critical point. Remember your domain, hit play when you're ready. So I'll have my interval, and I'll have my sign of f prime, so I'll go ahead and set this up. Okay, now for test points here. So you can actually figure out whether these intervals are increasing or decreasing just by a strategic choice of point. So for instance, in this interval, so 1 is a good choice because this comes out to 2 minus 4 minus 8. So that's definitely going to be negative, right? So that'll be negative. And then if I choose something like 8, maybe in this interval, so this would be 16 minus 4 minus 1. So this will ultimately end up something positive. So you can kind of think through the signs like that. And so now we can summarize what our intervals of increasing and decreasing are. Okay, so there we go with that. And so now that we've summarized that part, now we need to talk about max or mins. So let me clear some space. And you can see by looking at the table, so we're going from decreasing to increasing. So that indicates that we've got a min here. And since this just goes from decreasing to increasing, and it never goes back to decreasing, we can actually say this is a global min. So I can go ahead and categorize this. So we've got a global minimum at x equals 3.236 or at this point, so that the minimum itself is negative 11.867. And remember, you plug that into the original function. So that'll cover it for this example. All right, so I would recommend for this one, so notice that the domain is actually given to you, so this is going to kind of change everything up. So if you want to do this with me, let's start by first, we don't have to do anything with the domain, so let's find the derivative and the critical points. Hit play when you're ready. So my domain in this case is going to be cosine of x plus sine of x. Remember, the derivative of cosine is negative sine, so this will become positive. And then if I set this equal to 0, well, what will end up happening here is you get cosine of x equals negative sine of x. Divide both sides by, well, you can divide either by sine or cosine, but I would rather have, I'm going to divide each side by cosine, so I get 1 equals negative tangent of x, not tax, tangent. And then I'll just bring this negative, I'll divide both sides by the negative to get this. So my critical points then are just found where the tangent of x equals negative 1. And so you might have to bust out your unit circle to kind of figure that out. But your points would occur at 3 pi over 4 and 7 pi over 4. So these are your critical points at. Okay, so we've got that part. So next up, let's move on to the table. Now keep in mind that you've got this domain, so you just want to be careful when you set it up. If you want to go ahead and set it up and then hit play for you when you're ready, go for it. All right, so I've got my interval, and then I've got my sine of f prime. Okay, so let's chop this up. So I'm going to start at 0, and then this is going to be 3 pi over 4. And then I'm going to have 3 pi over 4, 7 pi over 4. Okay, so there's how my intervals are all going to get set up. And so if you're playing along with this and you're plugging in different values here, so again, it might be really in your best interest to have the unit circle so that you can kind of think through all the signs. But again, you can still use the same reasoning, right? So something between 0 and 3 pi over 4, I could just choose something as small as like pi over 6. And if I just think about the nature of the signs and where this falls in the unit circle, so if I were to plug pi over 6 into this, so these will both be positive because of just where it lands in the unit circle. So two positive things being added to one another, this will end up being positive. And I can continue to extend that logic and kind of play around with this. So I will get that this is negative, and then this will once again be positive. So you might want to have the unit circle next to you when you do this. And now for the plot twist. There is something very different about this problem from all the other ones. Can you see what it is? It has to do with this. This is a closed domain. So when you have a closed domain, talked about this in other videos, so I'll include a link to that in the description. When you have a closed domain, you have to test the endpoints. So this is something that is clearly a closed domain, so we have to not only test our critical points for maximum and minimum, but now we also have to test our endpoints. So that's a little bit of a plot twist here. So I can see by looking at this that from here to here, I clearly have a maximum, and then from this interval to the next, I clearly have a minimum. But now this is not necessarily enough, so what I want to do now is I actually want to kind of list everything out. So I'm going to plug in my endpoints, and I'm going to also plug in all my critical points, so I'm just going to evaluate all of these. And so now that we can see kind of all the points, so we can really clearly pick out, here's where my global max is going to occur, and then here's where my global min is going to occur. So that's thanks to the extreme value theorem that we definitely have that. Now, one other thing that a lot of books will talk about is what to do with these endpoints and how to think of them. So this requires just a little extra discussion. So think about what's happening at 0. So let's actually maybe just write out. So here I am at 0, and here I am at 2 pi. Okay, so if you think about what's happening right at 0, the function immediately starts increasing, right? So I'm starting over here at 0, and I know I start at -1, and my function starts increasing, right? So then what this looks like, actually, if you think about just the behavior near here, this point here at 0, this is actually going to look like a local min, right? If you're just kind of viewing the graph, you know that the graph is going increasing and then decreasing, and then, let's see, I guess I'm kind of botching this, aren't I? I'm increasing, decreasing, and then increasing, right? Here's kind of what the behavior of the graph looks like. So if you think about that, if I look just at this piece, this part looks like a local min because everything's kind of increasing from here. And then on this side, well, if you were to like think about continuing maybe this pattern, so this side looks like it's about to turn into a little peak right here where it gets cut off on the graph. So this we could actually think of as a local max. So this is a really weird thing, and I don't know that all books will talk about this, or that all instructors will expect this, but I was kind of looking around in some books and I saw this actually occur, so I wanted to talk about this. So this has to do with kind of the behavior of what's going on at the graph. This is acting like a minimum here, and this is acting, maybe I'll get rid of the 2 pi over here to make it a little easier to see. This is acting almost like a maximum over here. So you might find some solution manuals also kind of spell these out when you have a closed interval like this. To me, the bigger thing would be that you have the global max and the global min. To me, that's kind of good, but again, it just kind of depends, so I wanted to talk about that. Okay, so that's everything I've got for this video, so that actually concludes this series. So if you have any questions or comments or feedback or anything like that, you can leave me a comment, and if you want to give me a like or you want to subscribe, I'd super appreciate it. Okay guys, I'll see you next time.